but they're all genders, so it should work.
Not like
then, like we do a lot of sensors and cameras and stuff. So if you see some weird device, please don't touch or take pictures of it. And then we have like Ethernet ports everywhere, but please don't plug anything in. If you find
Take
US,
no responsibility what happens.
yeah, exactly. What happens is I will get IDS alert in my phone, and then I have to check out stuff. And it's super tired, so I'm gonna skip that today. Anything else? Anything that I missed? Nick said that. Anyone? No. We have beers in the kitchen, and then we are kind of environmentally friendly, so we have like metal and plastic and different bins for everything. Yeah.
Swags.
Yeah, swags. Yeah, we have a swag table over there in the kitchen as well. If you haven't pimped your computer yet. Yeah.
I need to fix this.
Yeah.
It's really disappointing.
Yeah.
Disappointing. Very well. Anything more practical? I don't think so. We'll start off with first thinking about what is this Meetup group and what is Cloud Native Nordics, how is this all together, and how can you participate. Also, in other ways, you don't have to be a Kubernetes expert to help our community be able to run these events and like make stuff work, because we're all here on our free time. It's nobody's paid job to do this. So we have a lot of nice things we want to do, but not that much time. So that's why we're also looking for people to help join us. I mean, it's community effort, spreading the word about Kubernetes, CNCF, similar things. And after that, I will introduce you to Kubernetes, Cloud Native, and that kind of stuff. If you don't know it already, we believe it's a good custom to do that at least at the first meetup, so that everybody's somewhat on the same page. After that, we have pizza.
Yeah. 18, I think they arrive at 18.
Yes, at 6 p.m. And after that, we will have some more real, practical thing about how Kubernetes works and how we can use it from Anton. And lastly, we have Sachin from Microsoft telling about how to do service meshes with Linkerd. So exciting stuff. And in the end, I don't know, do we have a hard stop at 8 p.m. or no? Yeah.
No, it's just there.
Perfect. So in the end, networking, we'll see how long people stay. We probably have until
a
couple.
Till 9 or something.
Yeah, something like that.
Be restored
Yeah. So we usually have these like 3-hour slots officially, and then people stay as long as they want, and the the venue can take it.
Yeah. When we did the front end meetup, we moved to the kitchen, and then like we restored this room, and then we kept on until like 11 or something.
Very well. Let's talk community. So Cloud Native Nordics. This logo is made by one guy in Tampere, Andrei Fadiev. Perfect. We said we wanted to have some cool logo, and we have actually two, or one logo and a couple of mascots. Pretty nice, and then people were excited to see this. What is this thing? Well, it started out as myself and other people doing Kubernetes and in Helsinki and Tampere, and other CNCF ambassadors in Aarhus and Stockholm, working on their own, right? Starting meetups, running them, trying to make sense of stuff, but not having an actual structure of what we were doing. So that's then what we started thinking about. Well, let's collaborate using speakers, sharing speakers, sharing data about our speakers and talks. So like we have a list of slides that have been presented, talks, trying now. We're really in the beginning, like basically we're a week in of our live streaming effort. It's getting better and better every time. I just bought the cameras, and Oliver have a lot of stuff, and getting stuff up and running, so we can be not self-contained, but like we can manage pretty much wherever we go with these, and don't have to rely on the venue. And now we're spreading this across this community, providing best practices how to do different things. We're in the process of formalizing roles for organizers, co-organizers, guides for how to run a meetup. And one thing that we had last week, was a roadshow, a tour. So we had two speakers, Russ Miles and Alexander Sowitzki. I messed it up again. Sorry, sorry, Alexander. From the UK and Germany, coming from Lutz and Chaos IQ, and we basically had a week of them traveling this route, presenting at the different meetups and coordinating everything. That was really fun, and people liked it a lot. The talks were really great. So it was a fun weekend, and then it culminated in the Helsinki Helsinki meetup last Thursday at Nokia. So this is one. We're hoping to do more of these. We also had a couple of meetups ago. Jessica Andersson from Göteborg. I've been to Umeå and Aarhus and a couple of other places, sharing, making us move, and also with this live streaming, we're able to share the content in digital ways too. So in some numbers, this is who we are, and we are trying to as a community get to collaborate more, get to share our stuff, and be open to new ideas. So, for example, when counting the meetup.com members across our 12 meetup groups, in all of the Nordic countries, we're 5,500 at the moment. Nearly every one of these 5,500 have gone to an event, and we have around 2,600 unique people across the different places. We also have nearly 120 registered speakers that we know have been at these. So that means if we have a list of 120 speakers, if we need someone, we might be able to, oh, you presented at the Stockholm meetup and you seem to be able to travel. Does it work? And et cetera, et cetera, et cetera. So now we have 90 meetups. We're hoping to grow this probably to 100 by the end of the year. So how do we do this? Well, we have the meetups by pull request pattern, which is a pretty nice thing. So basically, we have a YAML file in each of these directories, and to that YAML file, you add your who's been speaking, who's sponsoring, who's doing stuff, and when do we do it, and then it's a Go binary of written to that also fetches from the meetup.com API and fills in all the other details that is not human generated. So that's so if you need to know something about Cloud Native Nordics, go into Cloud Native Nordics/meetups on GitHub, and you'll find nice README files. Not as nice as the website though, which we're working on. Myself and Kasper Nissen, the guy in Aarhus, is gonna have a talk at KubeCon in San Diego in 3 weeks about this collaboration, and we need some more also front-end guys, people to help us out with getting the website, because neither of us so far are front-end developers really, more system integrations, that kind of stuff. But it's the website we have running is Vue.js. We have then a bridge from this. It sources the data from these and presents it nicely, so you can search and see what it's all about. And everything is obviously running on Kubernetes. We have GitOps workflows and all kinds of automation with GitHub Actions. It's like we call it KISS, Kubernetes infrastructure for static sites. Absolutely overkill, but but just to demo some things. Right. As I said, we're live streaming this because, or both because we want to be able to share afterwards to the people that couldn't make it, but also if you're happening to be in Turku and you can't make it to Helsinki for a night, then follow the live stream. But you still can get to participate in this community from online. And yeah, go in and follow us there, and you'll find all the things when we're live streaming with this kind of equipment. And also slides are linked and that kind of stuff. T-shirts. These are really nice. We have another model too of, I don't think I have a picture, but like basically some mascots with a couple of Vikings. We just bought a couple of ones sponsored by CNCF for San Diego, and we're gonna have a not meetup like this, but like, well, probably meet in a bar or something for all those people who gather there from the Nordic countries, and distribute them. So that's the first batch, and then the second batch is going to be that we can distribute them in every of these 12 meetups, but that's logistically harder to get to 12 different places instead of one. But if you're interested, we at some point probably need some sponsors or something, or at least what you need to do to get one of these is to join our Slack channel to say that I have size blah and I'm interested in getting one. So Slack, cloudnative.nordics.com. That's currently showing the old website. We're hoping to launch a new one soonish. And we have a mailing list where we share Google documents and different stuff we have in the drive. For example, we have what is it called? Community meetings every month. So that's Wednesday, the first Wednesday of every month. Yes. So what is it this month? 5th? Something. I don't know. Next Wednesday. Yeah. And meeting notes, and they're recorded public too, also uploaded to YouTube. Yeah, here is the other logo, right? I had a picture. Cool. So, and also now this slide I just added like literal now. I just want to touch on the code of conduct briefly and say this is a CNCF event, not officially organized by CNCF, but it follows the same code of conduct rules, which in short means be respectful to each other. We don't tolerate any discrimination or all these kinds of not fun things to talk about. So if you it's pretty lengthy. The full reference of this can be found here. But in case of any violations of this, you can contact any of the organizers. Yeah. So, and also, yeah, there's one other thing too. Is there anyone here who is not comfortable? So if we take photos and we have a Twitter account, photos and tweet them, is there anyone that is not comfortable being on that picture, and we won't upload anything? Okay. Then we won't upload pictures this time. That's fine.
This live stream is okay.
Sorry.
The live stream is okay because it's.
Yes. So this is another result of the meetups by pull request thing. We can now visualize who's been active in Finland. These are the companies who have either been sponsoring, like Walkbase today, or have provider speaker, like in this case, well, today it's, well, kind of my company, Microsoft, and Walkbase. At other meetups, other things. But it's going fairly well now. Now we actually start to, and also I start to get a picture of who's doing stuff here in Finland, like who's active in these kinds of things, and who's thinking, developing, etc. And yeah, if you want to be on this this picture because you're doing stuff with Kubernetes, then contact any of the organizers, and we'll give you a speaking slot. And if you're anyways want to get on this kind of slides that I present pretty much at, well, virtually at every meetup, is the like ecosystem members. So like so you can just go to this Google form and say like, hi, I was at this meetup today, I represent company XYZ, and we're doing a lot of fun stuff with Kubernetes. And then we'll put your company up here, and this is basically a kind of a, you could think of it as a backlog too, like the companies yet to speak in Finland, because we know they're active. So this is like a way to get some visibility and maybe also step up during some future time. And that leads us to speaking. This is like, again, community organized event. Anybody can speak as long as it's relevant and has something to do with Kubernetes or Cloud Native. If you want to do so. And another thing which should be mentioned is that it doesn't have to be that complex. Often, like what I've noticed is people say they've done a lot of nice things with Kubernetes when I talk to them like this, but then I say, can't you have a 5-minute talk during the next meetup? And they're like, oh no, no thank you. So like, cause it's not good enough. But it is. So I mean, it's nice to see when people are doing stuff, and it doesn't have to be like, your deployment doesn't have to be CERN level with 300,000 cores. It can be really like you did something, you failed at some kinds of things, and you then noticed that, oh, Kubernetes actually works this way because it's so extensible and configurable. So now we fell into these pitfalls, but we fixed them, and now it's working well. That is a really good story, and then also might give you connections you otherwise wouldn't have in this from this kind of venue. And yeah, the Cloud Native Nordics mailing list is also a good place. Occasionally we'll probably use this for, and the Slack channel, use this for searching, looking for speakers. So like we'll ping things there like, oh, we're missing a speaker. We're actually missing a speaker for the next Helsinki meetup, and probably Tampere and Turku too. We have like 3 meetups coming again in like this week has been 3 meetups, and in approximately a month we're missing, or we have 3 meetups more, which means 9 speakers. So we're looking for 9 speakers until the next month, which is the work that why we need organizers, right? And why we need people to be active. Very well. Any questions? Any other comments from?
One thing we have done here in Turku is that if you're a company and you want to host but you don't have the venue, like you have a small office or something, we had discussions with the guys at SparkUp, and we are welcome there. So we can also like arrange a meetup there and have you as a host. So not having a venue is not an issue here anymore. So.
That's real nice, yeah.
Anything else?
I don't know, do we have questions about this kind of collaboration, meetup, alliance, whatever we could call it? Anyone going to KubeCon San Diego?
Far away. One thing is good with this cloud native Nordics, like that it's not just about Meetup. There are like different channels for all kinds of topics. So let's say your container isn't starting on your cluster and you don't know what to do, or you just want to start out. You can always go in there and ask a question, and there is always someone who reads through and responds. It's not as like spammy as the main Kubernetes Slack, where you have to post your message a few times because it's so active. So that's really good. The cloud native Nordics, like I think.
Yeah. So
Should we go on?
then we have that's the introduction, the like thing about what the community, and now proceed with the talk.
Yeah. Sure. Should we take like?
We could have a 5-minute, 10-minute break.
10-minute break, and I get my
Sweet.
stuff set up.
Yes.
Yeah.
Okay, perfect. Okay, so I will go on presenting here until the pizzas are here, and then we'll we'll eat them. Quick introduction. I'm CNCF, but currently I'm studying at Aalto, freshman, first year student there. I've been for the 2-3 years Kubernetes special interest group and work group lead. We'll see more what that means later, but also spoken at a couple of KubeCons when we still had maintainers. I had that title, but no. Also, we're gonna look at what kubeadm is and different other tools I've been doing, and how you can get started with Kubernetes. Anton will also cover. So, I've been contracting for WeWorks too. Yes. So, what is CNCF? Compared to some other things, which are cloud computing, and this is really very not maybe describing so much what it is, but if we would go to one line, open source, well, everything in CNCF got to be open source. Cloud computing, it's thinking about these cloud native things, which we'll describe in more detail later. But unless some other tools in this cloud area and cloud sphere, this actually focuses on applications, not on the infrastructure that runs these applications. So we'll see what that difference is. So non-profit is part of Linux Foundation. It's been, it soon turns 4 years. And what its main task is to promote and help a toolkit of trusted projects. So they curate this set of projects that then is like can be trusted when going into your cloud native journey. So in other words, it looks like this. So we have Kubernetes, which we're all intrigued by and amazed by its kind of growth in the last couple of years. We have Prometheus, a rock-solid monitoring system, aggregation daemon, pioneering that space for highly fluctuating and dynamic environments. Envoy, a service load balancer, basically Nginx but C++. I don't know, cloud native with added bells and whistles for also this kind of maybe not before seen fluctuating environment and then like scale. Then Core DNS, really nice project, doing exactly what you think it would. DNS server, and it's very small core. It's doing what it should, has a declarative API, and a lot of extensions, which you can, with a simple, or with a small amount of Go code, you can write your own extensions to it. So that's really interesting. And then Containerd, Docker, you might know. And this is basically so what Docker initially was became split into 3 parts. So the lowest layer part, the container specification and the image specification and how to push and pull content to registries, that became a different OCI foundation, so Open Containers Initiative, which is like a sister or brother to CNCF, that's whose pretty much sole task is to guide and steer this container format to be open to anyone and free to contribute to. But then the middle layer, the thing that actually handles the containers and like is a runtime for these set of containers, because OCI is only one container, became Containerd, and that was donated to CNCF. And then Docker is like a wrapper around Containerd, providing more like the things it used to, and providing the higher level, for example, build functionalities and many other advanced features. But as part of this, now that the low-level container runtime was out there and extracted from Docker and in CNCF, everybody can now build their own container runtime kind of on top of containerd. I actually did that this summer for VMs. I did normally you think VMs would be, or are started in minutes or days or whatever. And you need to boot an ISO file and do configuration. But I did actually originating from the Finnish military. I did some programming there and interesting stuff. We then made a kind of VM runtime so that you do Docker build once. You go from Ubuntu and apt-get your stuff, then ignite run. It's called Weave Ignite today. Ignite run, and boom, a second later, you have a full-blown VM. So, and that builds on top of containerd, and that's why it's so powerful, that you can do many different things that wouldn't be. I mean, I didn't have time to. I focused on the VM parts and how to integrate Firecracker, Amazon project, which is doing the low-level KVM stuff. And how I was focusing on how to integrate these projects, not how to write a container runtime, because that's insanely hard. So containerd is a really solid building block for this. And FluentD for logging. So you can think of it basically as doing the same as Prometheus, gathering, aggregating metrics from like a lot of different places, but then for log streams and how to stream that to some kind of persistent storage, like Elasticsearch at the end of the day. So these are the graduated projects that I introduced here. And if you read the book, Crossing the Chasm, basically we have, that book talks about this kind of curve. Well, you probably recognize this from maths, if nothing else. From before, but then in this context, these are the ones that have crossed this chasm. Like it's very hard to get from the place where you have some cool stuff and you create a project, put it out there, and then you actually need to get all the other meta stuff kind of working. You need to get people talking about it, you need to get people working on it, using it, helping, etc., especially for open source projects. And once it's actually crossed the chasm and it's become mainstream, is another word, it's then a graduated project in CNCF. So you can, another definition of graduated projects in CNCF is that you can do a startup based on it. So like today, you could start a startup focusing on making some Kubernetes solution. And that's totally fine. I mean, we have, as we're going to see, we have like hundreds of companies doing exactly this. So and same for the others. That's one of the definitions. And then incubating projects, proven to have like good documented end users, let's say, and fairly stable, working well, but still maybe not the kind of stability that you would expect from a really, or maybe not in that sense ready quite yet for this kind of mainstream adoption. And the sandbox projects are the really early stage, people's random ideas. Maybe this works. Let's try it and have this project, and then they are here. So now we're going to soon have pizza, but why we need CNCF is that they started this in the same way as we have our meetups by pull request. Here is like landscape by pull request. So like they said, who's doing these cloud native projects? PR if you want to add yours. And now, like a year or two later, we ended up with this, also known as the cloud native hellscape. And this is why we need CNCF, right? So like CNCF has well, a lot of companies like putting money in one place to distribute to these projects for everybody's benefit, but also it has to distinguish that from what's actually good tech. They have a set of 9 top technical architects, really veterans in industry in that sense. Well, you can see, for example, I think at least 2 or 3 co-founders of Kubernetes are in that technical oversight committee, choosing like picking these projects, setting the terms of like what are the criteria for these different levels, and also vetting the projects so they're actually solid before they come into CNCF. We also have cases and examples of projects that have been in CNCF but then not met the quality bar over time and been removed. So this also happens, but this helps you with choosing, because if your company is gonna go on their cloud native journey and have to try out every database out there or every streaming and messaging service, in 10 years you're gonna still like keep on trying. So this is it's all about trust and helping you on this journey like this. So yes.
What does it take for a project to graduate from innovation into the graduate level? What is the criteria?
Now we have some random spam email there, sorry. Yes. The question was, what does it take for an incubating project to become a graduated one? And let's actually look that up, the exact terms. So technical oversight committee. So again, everything about CNCF is on GitHub. So like it all follows the same things. And here we see the members of the technical oversight committee. They meet their public meetings. You can also help in different ways there. And we have the process. There. So there is the full list. So there we go. One of the things which I've seen is the Core Infrastructure Initiative Best Practices Badge. That is like a very sophisticated thing. I went and checked it the other day, and like it's a fair amount of bullet points you have to check as a project, with everything from meta stuff to from like who's contributing and how, and what processes, what governance do you have, and like all these different things, and like how is your code tested, is like do you have practices in place for when bad stuff happens, and like end-to-end integration, all these kinds of different things. Just one of these bullet points, like this is massive work. Then yes, the third-party security audit is really, that's fairly, so let's say Kubernetes graduated before it had this, but it was, they did it kind of in meanwhile, and like, yes, they did find that they did find maybe 10 smallish things, but overall, with these kind of systems, like I'm not going to say like new CVs are created over time, but yes, they are. So this is an ongoing process too. But to graduate, you have to pass this kind of thing, or at least you do it and then you fix all the things, right? Before you graduate. The code of conduct, very important thing again. Then the governance is a big part of it. And Kubernetes, we'll see here soon, about how Kubernetes governance works, but it's a very large project. Like last time I counted, like 40,000 contributors, more or less. So like you have to have some structure in there, then yeah, this adopters thing is with Kubernetes maybe not so important, but because there's so many, so we can't fit them in a MD file. But for other projects, very important, and this is one of the criteria to step up the ladder of these, that you have so-called like public backers of your thing that say, yes, we run this project ABC with 1 million requests per second 24/7, and it's doing our production way better, that kind of stuff. And then yes, like you have to overall convince these top technical architects that your stuff is solid, and also with this supermajority vote. So these kinds of this is what's documented. There's probably more around it. Like you generally have to make your project be very, very solid, and it takes probably many years to be able to do this. Judging from both like containerd and core DNS, probably at least 3 years from like starting your thing, having a lot of like backers, that maintainers that work on it as a full-time job, maybe 10, 20, and then for 3 years, maybe then you can graduate. So it's fairly strict. Does that answer the question? Very well. Right. And then I'm not going to talk too much about this, but this trail map helps you, and then like it's also online, available online, in what to do at what stages. So like we have a really nice setup in today, in the sense that I will cover the really introductory stuff, like, and pretty broad, and then we go into like actually using it, and then we go into using advanced features with Linkerd here. So that's going to be really nice, and following this kind of path is pretty important, because you can't start with, well, in this case, you can't start with Linkerd before having a Kubernetes cluster. So you have to you have to follow some kind of guideline, but it also helps you with this thing. So like you don't start in the wrong direction. Right, but I saw the pizzas arrive, so let's take a break and eat in between. getting tech to work.
Are you back?
What?
You're back with the sound. I put it on.
Okay, perfect. Yes. Thank you. Perfect. So I talked about the trail map. Next is what is cloud native. This I'm not going to run through all of this. That's why we if I run my my WordPress instance, one WordPress instance for my whatever personal blog or something, we're going to see and that you saw in the cloud native landscape are complex, right? But there's a reason why they're complex. That's because they scale, which is the trade-off and what you also have to think about when deciding, do you actually need that complexity? Can you manage with something that is simpler but not as cool, right? Because sometimes it pays off. Sometimes it doesn't. If you scale to 5,000 nodes, then you don't manage it with bash scripts, hopefully, and use Kubernetes. But if you have one node, you might still just do Docker run. So that's that. Then public-private hybrid clouds, all these multi-cloud buzzwords and blah blah blah. But the key here is like different environments. It should work similarly, at least. How can we make it work similarly? Yes, we do stuff declaratively. We have some. We record the intent of the user and try to reconcile and make that happen in the environment. When looking around in that environment, we're trying to make sense of the information, the intent of the user there. So that's one of the keys of Kubernetes, for example, which runs on everything from Raspberry Pis to like CERN cluster with CERN clusters with these, like whatever they said last KubeCon. I think it was 300,000 cores. Right. Then declarative APIs, we're going to see examples of this later, but it's really the core, and the APIs of Kubernetes are maybe even more important than the Kubernetes runtime itself. You could argue that the idea, the lessons learned from when Google had their Borg and Omega projects were these kinds of things that we don't do SSH anymore, but instead specify intent and then act, have many different actuators on that. Then loosely coupled, resilient, manageable, observable, automatable, all these kinds of things we get as, not as side effects, but we obviously have to make an effort to make them so, but it's at the core of what makes cloud native, and cloud native is not the same as cloud. You can put your thing from 20 years back on the cloud, but it doesn't make it cloud native. For it to be cloud native, you have to adopt a different kind of mindset, and we'll try to introduce you to that kind of thing with these 3 talks today. And yeah, then what does these things give us? It gives us the different environment support and no lock-in. I can still take my stuff from the cloud and put it on my Raspberry Pis if I want to, as long as I don't depend on anything other in that cloud. But then we actually can do high-impact changes, continuous delivery, for example, and then this all with minimal toil. Like already in Kubernetes 1.2, which is 14 releases ago, which means Kubernetes releases every 3 months, so 3 years, 4, yes. So 4 years ago already, the Kubernetes team did a demo of a stateless application indeed, but a stateless application web server that was running with 10,000 maybe replicas, and then serving 10 million requests per second while being upgraded. And that kind of stuff you could get already then 4 years ago with that version of Kubernetes. Today you can get more complex things too. But then you can actually start doing stuff in a new way, because you have that kind of, you have the thought about it in beforehand, right? You have the prerequisites laid down. Okay, so that's cloud native. We'll see a couple of more examples later. Now a bit about what CNCF helps with all these kinds of meta governance stuff. So Kubernetes is a very complex thing in the sense that it has a lot of configurable. So it's very, very, very extensible. And if something is extensible, then the matrix of different configuration options grows insanely fast. So like, I can't even count the how many options there are, but say that we have like 7, 8 core-ish components, and all of them have like around maybe 200 flags or something, then you can see that. And then you install things to different environments and in different ways, and like different like TLS setups and like whatever topologies, not to mention. We see that it really gets super complex because of the diversity of different people's environments. It's like, it's a natural thing, but it's a very hard problem to solve. So that's why we have the certified Kubernetes program, conformance program, and that basically is a Go binary with a lot of end-to-end tests built in. So like, it talks to a Kubernetes cluster, schedules different things on the cluster, and makes sure that the cluster behaves accordingly, as it should, like as per the specifications. And if you can submit this against any cluster you created, and if it succeed, all the 300-something conformance tests succeed, then you know that the basic functionality of the cluster is the same between different places. So if I rely on this basic functionality, I will have the same experience in Google Cloud and on my Raspberry Pis, on Amazon and like Packet and all these things, or my homegrown service setup. So that is very nice. And then obviously people have done a lot of these certifications, and again, this is by pull request. There's a repo. If you're conformant, then like add a pull request with what version did you use, what is the output of the conformant test, how do you reproduce this. It needs to be reproducible, like so that anyone can just go there, execute the same things, and get the same result. If they don't, then you're kind of busted. So, but these have done it. Some of them are Kubernetes core, like Kind, Kops, Minikube, KubeADM, etc. And many of these other providers rely on these core tools and then build on top. But there's a lot of conformant providers, and it gives us a good base and some kind of unity too in the ecosystem. Then Kubernetes and Linux Foundation help with, for example, training. Obviously, a lot of corporates do this too, but on different terms, on other terms. So nearly 90,000 people have taken this free EDX course. It's pretty good. Check it out. Walk you through the basic core concept that we'll also do today, but a bit more, as it's self-paced course, a bit more extensively. Maybe, I think it was calculated to 2 weeks or something if you're completely new to the thing to finish. Then like there's a paid course too. Then when you have done this and you want to show that you're knowledgeable in this area, you can do certifications. These certifications are pretty hard. I think, well, only a fraction of those who take it pass. But still, it's a really nice thing once you have it. application developer is a subset of the administrator exam. So basically, if you're focused on how to deploy different applications to Kubernetes, take this one, because then you don't have to answer the questions about TLS and like how the components talk to each other using what interfaces and command line flags. But if you do that kind of stuff, that is a really good exam too, or certification. When you have as a company, when you have three of these certified administrators, then you can become a certified service provider. And that's like also helps end users make the right decisions. Yeah, I don't know if there's any more to say about that than this. Also, many companies there, because it seems to be interesting to people. Then CNCF arranges 3 flagship events a year, which are called KubeCons and Cloud Native Cons, or KubeCon for short. The next one, so we had one in Barcelona in Europe this summer or spring. Also one in Shanghai in the summer, and then now we have San Diego left this year. And then next year, Amsterdam, Shanghai, Boston. Check them out. They're really nice events. But if you can't make it, all the presentations are uploaded to YouTube. You can also watch the live stream from the keynotes. So it's you can get a lot of content. You probably, if you do that, you probably get more content out of KubeCon than me being in the like hallway all the time. So you can actually learn a lot from that. This has also, well, grown a lot. Some kind of networking way of networking, and this is third party. And it's well defined using CNI, Container Network Interface, which is another CNCF project. So another way to look at it is like you have infrastructure. You have that infrastructure can be Raspberry Pis, it can be clouds, it can be hybrid, multi, whatever, it can be on-prem, as long as it gives you some machines, right? And with machines, we then, on top of those, we run kubeadm. So you are on a machine, you SSH in. This is in the, like, not literally, but like, as you can think of it. On this machine, we run, for example, kubeadm, which has one single task. It is to get you from the place where your machine is only a machine with a, I don't know, blank Ubuntu, to where it has Kubernetes. And first you run kubeadm init on the first one, then join -- master or join -- control plane. Then for the other workers, you join and the token that you're given. Right, but we designed kubeadm because you saw earlier that there are like hundreds of these certified distributions, and they're all implementing this much code because they go from where you have nothing to where you have a full Kubernetes cluster with all the bells and whistles. Only this part is like 15,000 lines of code in Go, approximately. That it took us, our team in open source, maybe 2 years to write, to that level that it was considered GA, generally available. Kubernetes has very strict stability guarantees. That's why it also took a lot of time. But still, it's a very complex task because you have to get all of these 8 components and all their 200 flags each right, and all the mutual communication between these components that we saw earlier, like there's TLS all around here, and more. And this is a very simplified picture. But then layer 3 we can think of as like, because we can't really we don't do much with this cluster yet, unless it has some stuff that makes it more usable. And this is what I talked about with the scale. Like we optimize for the scale, and unless you don't need it, it doesn't make sense to, or maybe for someone, but in the general case, it doesn't make sense to have one well, it depends. It depends, but it might not be the fit for you if you have one master, you install Kubernetes, and then like all of these boxes on top of each other, then you have your app which is like 1% of that stack. Then you probably can do with less. But if you have this way, like 5,000 nodes, then you can definitely fit in some of the add-ons and stuff that make the distributed communication work. So this is the difference also between KubeADM and other, most of these tools that we saw in the certified Kubernetes are these end-to-end tools. So you have nothing, you run a command, and you get everything. But that's where binary view, so everybody has to do the same amount of work to get there. So we built this middle layer to help you along the way, also especially as a service provider. So how this looks in real life is, if you're on Ubuntu, you apt-get down KubeADM and some Docker, for example, or some other containerd runtime. Anything that satisfies the container runtime interface. Then you run one command, kubeadm init. We have a very, very extensive config file, which you can configure everything possible and impossible. Because your environment might dictate some rules. And then I said that the networking is third party. So with just kubeadm init, you don't have a functioning cluster yet, because you don't have connectivity between the nodes, between the pods, workloads. So you apply some kind of network provider. There's many of these, probably 20 or something. One of them is WeaveNet. There's Flannel, Calico, Cilium. Like, we were actually last week, we heard about Nokia. They had DANM, D-A-N-M. But anyways, it's pronounced DAM, and it stands for DAM Another Network Provider, or manager, sorry. And they have like one of these CNI plugins that, I don't know, manage them all. But it's like, that was the thing they had to extend Kubernetes with in order to be able to run to run Kubernetes at a telco scale and functioning, because they need dedicated stuff. And then kubeadm join for every other node you want to add. But the point of Kubernetes is to make it easier to build things on top. So like, I mean, there's many great things you can do with Linux, but if you just install, if you have a machine with just a kernel, it doesn't do much. It's everything that you add on top that makes it so brilliant, right? And how extensible it is, so you can make it function in ways you didn't think it could, like space. So here's like just, I'm not going to run through this, but like a list of some of the extension interfaces you can use with Kubernetes, because Kubernetes was designed to be pluggable. And these tweets are the more important ones. It's a platform for platforms. So Kubernetes is a platform which on top you build platforms. So that's also why there exist so many of these companies doing all this stuff, because the competition is actually higher in the stack. But unlike before, because before we competed across all the stack. So like companies competed, well, some of them do today, from the metal to like the user interface. But now we can start shifting towards everybody using Kubernetes as a base layer, and then on top of that, you build your stuff, the things you need. That is, well, not so important. Then special interest groups. This, as it's a 40,000 people project, you have to divide your stuff. I've been leading this one, and now I realize it's an old picture, but C class lifecycle and workgroup component standard for 2 to 3 years. And then we have a community elected steering committee which oversees them all.
Can you show the previous picture with the graphs?
This. it's not very up to date, unfortunately, but it just shows that it has a lot of momentum. What is more, maybe it's this one. Still, I didn't have time to update it yet, but it's like it says something about like the amount of people interested in it. So that's for my presentation, and next we have Anton. We're just gonna. Oh, okay, sorry. Yeah, perfect. That sounds good.
As good as Turku is, I don't want to get stuck.
Thank you.
I'm from Helsinki, so you know.
Thanks.
Here, well, Sachin gets a lot. This is Miro, the guy here, the healthier guy here in the glasses. What was your company?
Semantum, yeah, I work at Semantum in Otaniemi.
All right, I'm just going to put it
You
here.
have a tested Kubernetes. Well, it wasn't available 2 years ago when I wrote my master thesis. I wish it had been.
Oh, there it is.
Oh yeah. Yes.
I was just trying to put here.
And it works pretty much the same as naysayers.
Can you hear me now? On this one?
It's
Wait
not,
1 second.
it's just for the live stream. Is it on?
No, it's fine.
Yes.
It's good? Okay.
You're good, yes.
All right. Hello. And now that you know everything about Kubernetes, I'm sure you are ready to learn something about service mesh. Well, just like Lucas was saying, the reason why I think Kubernetes was invented is because running distributed systems is really hard. If you have tried to run distributed systems on your own, you will realize what all benefits Kubernetes will bring to you. And if you have not done or not felt the pain, then you'll be like, why am I running all of this, right? So service mesh is one of those things which you will realize the benefits after you have felt the pain. So in this talk, I just want to introduce what service mesh is to you. So at one point, when you feel like you're feeling this pain, come back to it and see if it solves your problems. So I'm not going to go through all the great glory of service mesh. I'm just going to explain how we used in one of our current projects and what problems we solved using service mesh. And this is a very tiny subset of what all Linkerd or service mesh can provide. But it'll just give you an idea of what kind of problems you can solve using a service mesh. So that's my talk, Linkerd service mesh, and how we used it. So first of all, what is a service mesh? So service mesh is like an infrastructure, network infrastructure level software which tries to take away your network level concerns from your applications and put them into an overlay network or overlay software. And it takes care of just doing this network communication between different services and provides you a reliable method of doing that network service communication. So that's the original intention of service mesh. You will notice that once you're able to provide this kind of reliable communication, and in distributed systems, reliable communication is hard, you can get lots of benefits out of service mesh, which were not originally intended, but you can use them because now you have this kind of ability to provide a reliable communication between your services. I talked about service mesh. Let me just say what about Linkerd. So Linkerd is a CNCF service mesh. It provides almost all of the features you would expect from service mesh, and it's of course in open governance, so it's CNCF. Unlike other service mesh, for example, you must have about Istio, which was pulled back, is not in open governance anymore. Which I think that's why Linkerd is so good, because you can follow up the progress. Also, having run Istio and Linkerd simultaneously, I can go on to record and say that I find Linkerd much more performant than Istio, because I feel like Istio takes up too much of your resources, while Linkerd feels like it's not even there. So with that, I'll just try to frame what I'm going to talk about Linkerd. So how does Linkerd actually work? So what Linkerd does is it installs in a sidecar manner a component next to your running application, and then it would change your softwares or your application's firewall or IP table rules to direct all the traffic to the Linkerd, which is the Linkerd proxy, and then it will forward it according to whatever rules you have set up to someplace else. So what it does is provides an out-of-the-box, highly instrumented network code, and you send your request to somewhere, it intercepts your request and sends it onwards, but it provides all of these network level stuff now. It can calculate what is the metrics and things like that. I'll just walk you through it. So the simplest is it just installs a sidecar next to your running service and then intercepts all your network traffic and forwards them. So it's just a proxy. And just by doing that, you get lots of benefits. So yeah, Linkerd has like basically in the architecture going very easily. Linkerd consists of 3 components. One is the UI to see everything, the dashboard. One is the data plane, which I talked about, which is lies next to your application in the sidecar. And then the other is a control plane, the Linkerd's components itself, which manage how the whole thing is running. It listens to the incoming request and it injects itself and things like those. Yeah, so you can install Linkerd very simply. Linkerd comes with a nice command line. So you can just do Linkerd install on your current, whatever your kube config is pointing to currently, or whatever kube context is right now. It will just see your cluster, it'll figure out what it needs to do to install the stuff, and it's very easy. And you can just do that and pipe the output to a file, so it will write a Kubernetes manifest file for you. I think I can just show you if it transfers, probably not. Can anybody help me? How can I shift the screen in this one?
I think it's easiest if you do a mirror of your screens.
Okay, then I don't see my notes.
Oh.
All right, okay, I'll just do it like this, no problem. So this is what the Linkerd file or annotation looks like. It's a huge file, installs a lot of stuff. You can go through it. The good thing is if you understand it, you can go through it. I do recommend it. If you are going to install Linkerd, you actually go through it and figure out the huge amount of configs you can do, but it also runs out of the box mostly. I mean, you can just do kubectl apply on this, and it will actually install everything for you. But I do suggest that you actually go through it and make sure you understand what all components are getting installed.
And you can think of this as assembly, kind of. Like before, like assembly code, that it's fairly low level, and will in future meetups will introduce you more detailedly to what these Kubernetes objects do and how these resources work.
Right. I assume, as I was saying, that now you are completely, you know, Kubernetes, so you are able to take up this one. But still, just stop me if you feel like I'll just try to take you through it. These are the Linkerd components which I'm talking about. This is the control plane of Linkerd. This is the Linkerd itself. So Linkerd itself installs its data plane with its control components. So they are itself instrumented. So you can get all the metrics, all things, how Linkerd itself is performing and what are the kind of things which it is doing. So, but these are the different components. Without going into too much detail, you will notice that there is identity. I'll come back to that one later. There is this dashboard here in the web, and there is this controller which calculates things, and this is the service profile validator. Anyways, this is how Linkerd looks like when it is installed. Getting back. Okay. Right. So, I said Linkerd you can install just by doing kubectl. In one of the CNCF meetups once in Helsinki, I introduced this bedrock. So I'll show you how we do it. So we have this, we use this thing called bedrock, which is just a method of specifying your high-level definition, and then you can just use high-level definition to install there. I don't think I should go into there. I don't want to confuse you more into it. But at the end of the day, what we are doing is we are writing a file like linkerd.yaml here. And we have this git ops setup. That is, instead of doing kubectl apply, you apply something to your cluster. We have something running in our cluster which listens to this file or changes in these files, and then whatever you supply in these manifest, it just applies there. Maybe we should do a GitOps talk later. Don't want to talk too much, but this is, well, it's easy to install it. Let's just take it at that.
It's like some people say that using kubectl directly, which is a Kubernetes command line client, is the new SSH. Like you, in the same way you SSH'd into your machine before, you now SSH into your cluster. So the better way is using GitOps like.
Right, you don't have to share your credentials outside of your cluster. The biggest benefit is probably that. And if everything is in Git, so you have auditability. Okay, I just showed you the Linkerd components, like how they look like. So let's just skip over that. How does it actually, so I also talked about this sidecar. Again, if you don't know what sidecar is, you're running your service in Kubernetes. It's like a pod. So you have your containers. So you just place your, Linkerd places its own container next to your container. So that's what is called sidecar. And the annotation is pretty simple. All you have to do, define is in your metadata annotations. So in Kubernetes manifest, everything is written like he was saying, according to a manifest. So you specify what is the desired state of the system. You just have to say Linkerd IO inject enabled. If this annotation is there, the Linked's admission controller, Linkerd will get a notification like, somebody says Linkerd should be injected. So it'll just go and install its container alongside your application. And that's how Linkerd will be aware that your application is in the mesh. So all you have to do is this. Just read the documentation. You have to define in the metadata annotations, and Linkerd system will pick it up for you. Okay, if you have this kind of thing running, so switching back to my switching is a little bit slow. I'm trying to make sure that we still meet our time. So I'm just going to show you a list of few of the things which are running in my cluster. So we have a few of the microservices we are running here, and you will see that each of them, for example, approval here, I'll use approval as my test bench for most of the things I'm showing you. You'll see that there are two here, and if I was to do describe on it or go through the container list, you will see it's actually the business logic of this microservice. It also has the Linkerd's proxy installed along with it. Okay, so the thing is, it was very easy to install all of that, but what do we get out of it? We are doing it for a reason. So the first thing I want to show you is like just by doing that, we got mutual TLS for free. Now, if you have tried to do mutual TLS between your services, we were doing this in a banking domain. So mutual TLS is extremely important for us. We don't want somebody to be able to install a pod in your cluster and be able to listen to everything which is going on, especially for banking. There's a strong regulation that you cannot do it. Everything must happen on TLS. And if you've tried to do mutual TLS among your services, you will know, you will have to install the certificates, and to make sure there is a CA authority which can revoke the certificates, and you have certificate credentials rotation going on. Good amount of work. We got all of this free from Linkerd. Because when Linkerd starts, it starts a CA certificate root, a trusted root authority. When your services come up, they contact this authority and generate a key for themselves. And each service has its key. And before the proxy sends anywhere, it just contacts the identity to make sure that all of the identities are correct and there is no man in the middle, which you're not sending to. So we get mutual TLS out of the box. We don't have to do any credential rotation. It's all for free. If you have a requirement for doing mutual TLS, becomes very hard. This is so much easier if you were just running a service mesh. No, that won't come in. I wish I could just switch between this and that, so otherwise I have to wait like 5 seconds before it comes back up. Let me just show you. I'll just do Linkerd edges. So what this command does is it should show me the edges between different components. So if you were just to note that, okay, it doesn't matter what's here and here, it just says the MoneyGram web UI talking to some component called blacklist. So there is an edge in between. So one service called the other service, and it was, if you look here at the right-hand side, they are all secured. They have the check mark, and the one with service which just says not provided by service discovery is not under mutual TLS. So if it was not implemented, you will see things like those, and that's for documentation because we don't care. I mean, it's just documentation. So we didn't want to inject Linkerd into our documentation pod. It's just documentation which is not there. So, but all of them are running mutual TLS, which satisfies our regulatory requirements to run everything through TLS. Got it for free. Didn't have to do anything about it. All right. There it comes. As I was saying, I think the original reason for service mesh to be invented was to have safe and reliable communication. Has anybody used Hystrix or has heard about Hystrix? If you run any of the JVM, Netflix OSS, has anybody about Hystrix? Okay, now, yeah. So Hystrix is this software provided for JVM languages by Netflix, where you're calling one service, calls another service, and well, services are not reliable, so it might not respond back in time. So you might want to do a retry. So at what kind of quality of service would you want to do a retry? Would you do a retry instantly? How many times would you do a retry? Would you do an exponential backoff when you're doing a retry? Things like these are provided by Hystrix. It's a great thing if you're on JVM. What if you're not on JVM? Well, there are all these ports for Hystrix in Go, in Python, in whatever language you're doing. But do you really want to like take so many different softwares in your system? I mean, if you have different languages, do you really want to do it? The question to ask is, why are we solving network level concerns in business logic? Like, why are we doing it at this level? Why are we not solving all of these problems in the network or some other layer? And that's the reason why service mesh was brought in. So Linkerd comes with this service profile for reliable communication. Initially, when I was showing you the components, you must have seen this called SP validator, which is like service profile validator. So what it does is you have an API for your service. If you just tell Linkerd that this is my API, it figures out what kind of service profiles you should write. It's very easy to write it, but you can write it manually also. The point is that there is this thing called service profile, and for your every call or for every API, you just provide the service profile, and then you get lots of things for free. So what do you get for free? So things like retries. So this is the spec. If you write the spec for service profile, you will see something like that. So you can read it clearly, like, okay, for this is just an example from Linkerd, so this is not ours. For this particular route, which is get API annotations, I want it to be retriable. That is, every time a service calls this endpoint, and Linkerd is able to find out using the host headers and the things like what you're trying to call. And if this is set is retriable, imagine that it sends you a 5xx response. Linkerd will wait and will retry on your behalf. So all for free. You don't have to implement it. You don't have to integrate Hystrix or any of the other ports in your language. You just have to define a service level metric, a service level profile like this. Of course, why doesn't it come automatically? Why don't we do retry all the time? Because, well, not every service should be retried. What if it's not idempotent? What if it crashes, like you don't want to hit it again and again, and if it crashes and it goes out of, you get a cascade, network cascade errors. So this one specifies, okay, what kind of retry do I want to do? In this case, we are saying, okay, we have a retry ratio of a 0.2, like the ratio of the good to bad should be about that. And we want like a minimum retries per second is 10, and the time to live is 10 seconds. You can read in the documentation what all they mean. It's pretty evident, or you can make out. There's some kind of metrics as to at what level do you want to retry that service. And if it fails again, then probably you will get the failed response back to your original service. But you can do retries without you having to write anything about it. Similar with timeouts. In this case, the timeout is, okay, what if the service is responding slowly? So similar kind of thing goes in, and it says like timeout is 300 milliseconds. If I don't get a response between this one, don't wait for it, send it back, and get another call in. Because this is a big thing in distributed systems. You might call it. I mean, it's very easy if you get a 5xx response, because it's dead, no problem. What if it is not dead and it's like just taking time? That's a big cascading error which you get in distributed systems. So this is one way to control it. You have like, okay, how many milliseconds should I wait for it? And at this point we say, okay, let's just read. So if you define your service profile using Linkerd specification, how you should do for your route endpoints, you will get all of that for free. So in our projects, we were doing it on .NET. So we wrote everything, and then we took everything out, and we just integrated like service mesh, and we used all of these features out. Okay, now this is, I think, the best one for me, because this would have taken a substantial amount of time. And again, it was substantially easy for us to do Canaries deployment. I'll just walk you through what Canaries is, but we use another component from Weaveworks called Flagger. And along with Flagger, Linkerd's SMI spec on traffic split, we could implement Canaries very easily. I can understand that this is a lot of things, but I just want you to take the inspiration from here, go read the documentation, and probably it'll make a little bit more sense. So what is Canary? Well, you're trying to deploy your software. Kubernetes comes with a deployment controller where there is this thing called rolling update strategy. You are deploying one microservice, and you want you don't want microservice to go off when you are deploying it. So you have this rolling update. You put a new service, it brings up a new one, and then brings up a second one, and then kills your old one, and then directs all your traffic there. So we already have a deployments controller. But what if you wanted to deploy a canary? Very quickly, canary is something like this. So you have a service there, and you have two backends which are serving it, in this case V1. So you install a new service V2 in this case, and you shift 5% of the traffic to that one and see if is it working? Is it working? Then you do 5, 10, 15, 20. In this case, we are doing till 50. So we are calculating 50% is going to old, 50% is going to new. Everything is working out fine. Our service is fine. People are not complaining. At that point, we start to change the old V1 to V2. Still, the traffic is going like that. Then we shift these ones. Both of them are V2. All of the traffics are, all of the pods or the backends are now running V2. We kill the old one, and we just promote it from V1 to V2. So this is called canaries. In deployment, in a rolling update strategy deployment, what we would have done is we would put 2 V2s, we would kill the old V1, and we would shift all the traffic there. And then, Hail Mary. Oh, I hope everything works fine. So yeah, this is canaries, and we got that for free by using this thing called traffic split, which Linkerd provides. In fact, it's not Linkerd. It comes from the SMI spec, which is a service mesh interface, because now there are lots of service meshes. So a little while back, Microsoft, along with Rancher and Linkerd, came up with a service. I think even Istio now has SMI implementation. So this is traffic split. If you just read this spec, it's very easy to read. It says that for my service called my website, I just have 2 backends, and I want to send 50% of the traffic to one backend and 50% of the traffic to second backend. Looks like quite what I was saying, right? So this is traffic split. So what we're going to do is use a spec like this to implement canaries kind of deployment. So I was just saying that we use Flagger. For that, Flagger is a tool by Weaveworks. If you've spent any time in Kubernetes, you will know about Weaveworks, so I won't go there much. Let me just show you how the spec looks like, so it becomes a little bit easy for you to. So this is the spec for Canary itself. So what does it mean is, when you use Flagger, this Flagger is a tool. It will install an API like this for you in the cluster. In Kubernetes, everything happens in the API. You just specify what you want to do using some API provided by something. In this case, Flagger provides that API. It's called CRD technically, like custom resource definition, doesn't matter. So this is some kind of API. It says, okay, in this particular API group, we have this kind called canary. And then there is a specification for the canary. It says, let me walk you through very quickly. So it says for one particular deployment is what I was just trying to explain to you. Kubernetes comes out of the box with something called deployment. For this particular deployment and this particular service, we have something, a canary analysis defined here. So we are just going to define what does it mean when we say we are running a canary test. So in this case, we say, okay, max number of, how many fail metrics are we allowed? So we say 5. Max traffic percent, so how much traffic do we want to shift to the canary, which is 50. And every step of the shift should be like 5%. And in this case, the metrics is like in 1 minute, for 99% of the requests should be successful. And the P99 latency for this particular service within 30 seconds is 1100 milliseconds. 1100 milliseconds. It was a really slow service. Don't judge a microservice, but it was connecting to some on-prem database, so that's why it's so slow. But anyways, the point is that you're going to run some particular test. In this case, this is a particular test which is being run on your new service with these metrics, and if the metrics succeed, the canary deployer would shift your traffic slowly. It'll kill your old one and bring your new one. So the logs look something like this. So it says, okay, new revision detected. Okay, let's start to do the canary rollout. It will wait for the deployment to run. And then you will see, okay, I'm now starting the canary analysis, shifting the weight from 5 to 50. Everything is working out fine. Deleting the old deployment and making the new canary as the new primary. So then it shifts all the traffic. But it will look something like this. Again, by using a tool, try to implement this yourself on Kubernetes or any other platform for that matter. Kubernetes makes your distributed systems easy, but even then it's quite hard. By using Linkerd and Flagger, we were able to implement this took like 2 days to experiment and figure out and make everything's running. And it was substantially easy. So that's why I'm like here, like the kind of thing you can get the benefit of by using something, if you understand what you're doing and you understand the concepts, could provide you a big productivity boost. But this is what Canary looks like, and we were able to implement it quite easily using canaries. Okay, yeah, so as I said, that there are a huge amount of features in Linkerd. There's very good dashboard. All the metrics are written in Prometheus format, so if you use Prometheus, you can scrape the metrics and put it. You can form your own alarms. It comes with a Grafana dashboard, but very likely your organization uses its own visualization tool. But anyways, all the metrics are in Prometheus format, so should not be a problem. And there are a huge amount of other features which you could use. These are the features which we used in the last 2 months or 3 months since we have been doing this project. But I suggest you go and try and see if Service Mesh fits in your needs. Linkerd did not provide us with too much of a performance hit, but having said that, whenever you provide some proxy, it will take some hit, so you have to make sure that does it fit your requirements or not. The last thing I want to leave you with is, well, that's all good, but if you're going to use a component like Service Mesh, no matter what Service Mesh, you have to ensure that your end-to-end observability, like your monitoring system, is to the par. Because if Linkerd fails, you're dead. Everything is going to go, because you're proxying everything through Linkerd. And if Linkerd's control plane is dead, and your monitoring is not good enough for you to inform that or restart or do whatever you do, then you're out. We had this outage. Okay, Linkerd is working out very well, and we didn't realize it. So there were some DNS issues, and we lost connection to the identity, Linkerd's identity, which means nobody could identify, and we have mutual TLS running. So we had complete outage. Like every service is down because of it. So you don't want to hit that. So if you're going to use some component like so critical to your requirement, make sure you have really, really good monitoring and end-to-end observability in place. Okay, with that, that is all I had to say. That is me. My name is Sachin. I work in Microsoft. I won't be here for too long, but if you have any questions, just let me know. Cheers.
Yes, so hello everyone. I'm gonna start this talk by asking how many here has fiddled with Kubernetes, like run Minikube or like run a cluster. Okay, so roughly half of the people. It's great. So yeah, this talk is gonna be about managing Kubernetes clusters easily with Rancher. First, who am I? 3 years at Walkbase. Out of those 3 years, for 2 years we have spent our time in the Kubernetes world. I grew up on a farm, so I have 18 years of experience managing cattle, and I'm also one of the organizers of this meetup group. For hobbies, I do home brewing, and then I'm into IT security. So yeah, I'm gonna skip most of this journey, but basically a few years ago we were still running VMs on bare metal down in Germany. One of our core components is Postgres, so quite critical. We get the performance there, and everything was managed by Puppet, which is kind of ancient in today's standards. Then roughly 1.5 years ago, we got bought by this American company, and they were like, "Hey, you guys, you should move into our data centers." So we got some VMware vSphere clusters, and from there the experimentation began. We had like a great opportunity to renew our stack, so that's what we did. These are all the things we tried out. We wanted to settle for Kubernetes. We did the decision quite early on, and then we started to test different ways to deploy Kubernetes and manage Kubernetes. Late 2016, Miro messaged me and said, "Let's go down and drink beer in Copenhagen." And then we went to KubeCon. At KubeCon, I spoke with some guys at the Rancher booth. I thought it looked interesting, so we tried out Rancher, and that's where we are today. So yeah, what is Rancher? Rancher is a Kubernetes management platform. Through Rancher, you get the full cluster lifecycle. You can create, configure, update, and all these kind of things. You also get some help on the day 2 operations, but I think this is the most powerful thing Rancher provides. Another benefit of using Rancher is that you get a nice UI for everything. If you have used Kubernetes, you have probably seen the Kubernetes dashboard at some point. The Rancher UI is that dashboard, but on steroids. It's also, everything is handled through APIs, and there is a nice CLI tool if you want to act with Rancher through the CLI. And excuse me, there is a lot of extra functionality out of the box. Like if you have heard about Helm, Rancher provides that natively to something they call catalog apps. You get a monitoring and alert stack by default. You also can get your service mesh through Rancher. Rancher's choice is Istio. It's a competitor to Linkerd, or like alternative, I would say. It's a bit more, I would say, heavy to run. There, yeah. And then you get pipelines, which is like CI/CD pipelines. And one good thing about Rancher is that it's fully open source, and if you want to, you can pay for enterprise support. How do you get started? Fire up a small VM, something like 4 GB RAM, 2 cores, and then you run this Docker command. This is the simplest way to get started with Rancher. And a quick mention, what Rancher uses when it provisions Kubernetes is something called Rancher Kubernetes Engine, or RKE for short. It's a CNCF certified Kubernetes distribution, so you actually get Kubernetes. RKE also works as a CLI tool. If you don't want to use Rancher, just RKE, that's also possible. And the only requirements is that you have Docker installed on your node and SSH access to the node. And then Rancher also has this small Linux distribution that they use. Basically, it's a small Linux box that only runs Docker. You have system Docker for the system services, and then you have user Docker for all your containers. And one nice thing with these container Linux distributions is that they are configured by boot during boot time. So you throw a config at the VM when you boot it up, and everything gets set up automatically. Okay, so demo time. This is world record pace right here. Yeah. Johan, what was the DNS name? Okay, so what you're gonna see here is Rancher out of the box. This is basically what you are greeted with after you have fired up the container. So we're gonna log in here. No. Would have been too easy. Normally it asks you for an admin password, like you generate it on boot, but I've already done that to make this quicker. So first thing you probably want to do is you want to set up a user for yourself. You don't want to run as the admin user, and that's done under the users tab. I'm not going to show it here due to the time constraints, but basically you integrate with your OAuth provider, and that's how you get your users. Then the second thing you want to do is you go in and you define some nodes for yourself. Wait a second. Yeah, so this is what you get greeted with. Choose your cloud, and then you define how many cores do I want. I'm gonna take up the vSphere UI because I'm more familiar with that. You basically define how many cores do I want, how much disk do I want. Do I want to provide it with some initial configuration, etc. Very basic stuff. Basically, you tell Rancher that I want some VMs to have 4 cores and 8 gigs of RAM, for example. And after you have done that, you are ready to deploy your first cluster. So we're going to add a cluster here. Yeah, that's something I also forgot to mention. With Rancher, you can also like import existing clusters. So let's say you run some small cluster on-prem, and then you want to have some easier way to manage it. That's also possible with Rancher. You press this import existing cluster button, and you get a small kubectl command that you run, and then the cluster connects to Rancher, and you can manage users and such through Rancher. But yeah, in this case, we're gonna deploy a vSphere cluster. We give the cluster a name like Gates L1, and then we want some API and etcd nodes, and we want the high available cluster, so we put in 3 nodes here. Then you click these boxes, like these nodes should both run the etcd and the control plane or the API server. And then here you select your node template. Then after this you can add like some workers. I'm not going to fill all this in because it takes time. Like after you have defined your base cluster, you don't have to be too explicit here. You can always scale later, scale up or scale down. You can add members. For example, if I want to give Lucas access, I can give him the link to our cluster and tell him to sign in with GitHub. And before that, I can add him here. So when he signs in, he has his cluster and he has the permissions that I gave him. For example, I can tell Rancher that Lucas is only allowed to read stuff in the default namespace, or Lucas can only deploy stuff in his own namespace. I think that's pretty neat. Then you select the Kubernetes version. They usually only like support up to the next or like the latest Kubernetes might not be available here, but they are pretty good at updating. So you can already get Kubernetes 1.16, which isn't that old, through Rancher. You select the network provider. For us, Flannel has worked the best, but if you have some own preference, you can go with that as well. Then if you use cloud provider, for example, for storage, you click custom here and then you fill in the stuff and advanced options. I'm not going to go through all these, but one big thing with Rancher is that instead of filling in these forms, what you can do is you can do edit as YAML, and you get this. Oh, no, it's not visible. You get this large YAML file that you can dump after you have created your cluster, and then you have your whole cluster configuration as a YAML file.
Yeah, we should probably distribute the YAML engineer t-shirts too.
Yeah. If you don't like YAML or you deploy lots of different clusters, they have this new thing called RKE templates. This is actually really new. This came out 2 days ago, I think. And what this enables you to do is that you can make a default template for your clusters. For example, everything that I filled in just moments ago, you can dump that into a template, and then I share this template with Lucas. And the only thing Lucas has to do is define that I want 5 workers and 3 master etcd nodes. I think it's a really good like convenience innovation. It's up there with sliced bread and these queuing apps that have just come out. After you have done this, another great thing with running Rancher is that nowadays everyone wants to run their infrastructure as a code. And this, like, you can dump the YAML, but it isn't really automagic yet. You can't run a command on your computer, and all your clusters come up. But what Rancher has opted to do is that they have a really big open source community, and through that community there are providers. For example, they have a Terraform provider, and I think this thing is super neat. Everything that I have done so far can be configured through this provider, and then instead of like if you want to migrate all your clusters, or let's say there's a fire in your data center, you can just have all your clusters as code, all users as code, and then you just run Terraform and everything gets set up for you. I think, yeah. So that's the next step after you have deployed your clusters, and then I'm still gonna show like the UI a bit. So this is what you get when you deploy. This is now, I think this is a 6-node cluster. As you can see, you have like some basic monitoring. This is straight from the UI. You tick a box, you get Grafana Prometheus straight deployed from the UI. And like it's really good for development. For example, when I work on something and I want to test something out, instead of testing it on a cluster that someone else uses, I can just spin up a cluster for myself, break the stuff I want to break, and then just tear it down by the end of the day and go home with peace of mind. Yeah, I have some basic applications deployed in this cluster as well. This is something, yeah, probably familiar to a few, but I want to I want to show off the Istio integration as well. Let's generate some traffic, hopefully. No, we can't. This is a nice thing with Catalina. It closes down your apps and saves resources in that way. So VPN has died. And it's not coming up.
Maybe the IP migrated.
No, it's should be. It's viscosity to the VPN. I use it like after it quits, it won't come up. I need to reboot this machine. But let's see if we have some historic data. So, like one thing I think, yeah, yeah. One thing I think it's that Rancher does really well is that it integrates with tools like the Grafana and Prometheus I showed earlier. Everything gets in the UI, so you don't have to hit specific URLs. And also, if you have multiple users, for example, if I add Lucas to my cluster and I only want to give him access to a certain namespace, the Rancher API handles that. So Lucas can only check Grafana dashboards for stuff that actually runs in that namespace. So he only sees the small part of the cluster. I don't think we have. Let's hope there is some stuff from yesterday. Yeah, this is another way they integrate. The graphs you see here are graphs that you normally could see in Grafana for Istio, but what Rancher has done is they have actually dumped the dashboards here in the UI, like natively. And if you actually want to go and check the Grafana dashboards, there is this small button here, and you get all the information from the service mesh. So why should you guys test Rancher? One great thing that they do is when you're new to Kubernetes and want to get something up running quickly, they have forms for almost every Kubernetes resource. So now let's say I want to deploy a new application. I want to deploy Redis. Then I can just do like this. Type in we want the latest Redis, and you get like a form for all the stuff. And after you have done this, you can press launch. It will create the deployment. Put in some sane defaults. It's not the same defaults as you would get if you would query the Kubernetes API server directly. They do some changes to the YAML, but it's pretty much the same, and it's a quick way to get up and started. Yeah, this was pretty quick, I think. I left out a lot of stuff, so it might have been a bit choppy. But if you have any questions about Rancher or starting with Kubernetes in general, I will be here all night. And if you want to click around, this is a test cluster, so I can probably let you do that as well. Questions?
VPN up and running now, so you could show.
Do I have? I have? No. Like this is what it does. Yes, it works. And this is Catalina. And this is the .1 update as well, so it should. Yes. So we do like this, and then we want to see. This is a thing that Linkerd does as well, or this is what you get out of a service mesh. You get a really good overview of your applications running. Oh, let's do a workload graph. Oh. It takes some time before the stuff actually comes into Prometheus. But as you can see here, all these green lines, this is MTLS traffic, and then you get you can see packets flowing, you get response time, you get percentiles, you get failures. And for example, here this reviews thing here, this is a service graph, so it only displays the service. But what's actually happening in the background is that we run 3 versions of the reviews service. The first one, which just serves reviews, then the second one, which uses a Redis thing as the backend, and this one should actually, I think it should have a bug, but the bug is bugging right now. Let's say it that way. Requests here should fail, but they don't do for some reason. I'm not sure why. And then we have a third one where the bug is fixed, or non-existent bug is fixed. But yeah, this is Rancher. I think it's a pretty powerful package, and I think it's a good way to start out. And it's like all things Kubernetes. You are not like cloud locked in. You can deploy clusters on GKE, and then the next second you shoot a cluster to Hetzner down in Germany, and these things. And we run all this on-prem. So this is on-premise Kubernetes.
Did you get all this by running that one Docker container?
Yeah, and if you want to do this in production, you probably don't want one container. So what you do is you deploy a high availability version of Rancher, and if you want to follow their docs, what you do is you use RKE and you provision a 3-node cluster, and then you run Rancher inside Kubernetes to manage Kubernetes. Because Kubernetes is really good to keep stuff up and running, keep state. So that's what you do. I recommend this one Docker container way, because then you can test it out, see if you like it. And if you don't like it, you can easily switch to something else. You don't have to spend like 3 hours to get the AJ version up and running. But I think this is actually pretty good to test out Kubernetes.
Do you have like a ingress controller setup?
Yeah, in this cluster I use Istio, but Rancher actually comes with the ingress controller. Like you can, when you create the cluster, you can tick a box, give me Nginx, and it gives you Nginx. And then after that, it asks you that do you want to run Cert Manager, and you press yes, and then you get Let's Encrypt certificates.
Yeah. So ingress is like the way you get out of cluster traffic, like from public internet into your cluster. That's a load balancing rule, kind of. So I was just thinking, if you have an ingress controller, if you could create a sample ingress to one of these.
I don't have an ingress controller in this cluster.
Yeah,
but yeah, if I would do it, I could do it to Istio, but I don't have any gateways that listen like that. Yeah, this is also a thing that I think is pretty neat. You can get lots of stuff done through the UI, but if you want, you have the kubectl anywhere in the cluster. I think it's tilde, and you get a kubectl, so you can do native Kubernetes commands as well here. But yeah, I think people have trains to catch and buses.
Yes.
Yeah.
20 minutes, I think it goes from Kupittaa here.
Yeah. This is also one thing. You get your kubeconfig file for each and every cluster. You get here. Just through a button in the UI, and I only have this config file, but at some point it gets quite tedious to have like several files, and there is this really cool tool called kubectx that I use. So it lets you switch between clusters pretty easily, and I think this is a must when you run Rancher, because it's so easy to deploy clusters that you get like after a day you can have 3 kube configs, and you need something like this to switch between clusters.
Yeah, but
unless you want to use the UI, but then you get Rancher's kubectl and not the kubectl and the aliases you want.
That's why you want to use GitOps, so you don't have
Yeah.
to mess with kubectl.
Yeah, but when stuff breaks, you
exactly.
have to take off your.
When stuff doesn't work.
Yeah.
But also, like when you mentioned the multiple clusters, like it's considered best practice to have more clusters. A set of smaller ones rather than one large one, or really large one. So that's it gets good, very handy.
I think in general on-prem Kubernetes was a really bumpy ride like a year ago, and during the last year it has like the whole process has smoothened out a lot. I think you can even get GKE on-prem nowadays, but they call it something else. It has some other code name.
Yeah, it's like all of these. But also in C cluster lifecycle, when we created these tools, it's basically commoditizing these kinds of things, so that all of these providers which provide, all of these companies which provide these nice dashboards can like have the same core among these tools. So don't have to, because that is a lot of code.
Yeah, it's
in Rancher or any of these similar tools. Yes. Question.
Yep.
When you Does Rancher provide anything for on-prem load balancer? Like if you have load balancer in the config, does it provide anything out of the
They don't provide anything out of the box, but there is this product called Metal LB. Yeah, and how they do the ingress on-prem, for example, is that they use node ports, and then so it's.
I was just wondering if it is integrated already with something like Metal LB or something.
No, unfortunately not. But yeah, for example.
They will probably do it at some point.
Yeah, or then, for example, we run on vSphere, and they are doing this new CSI and CCM. So there has been talks that should vSphere provide the load balancers. But yeah, load balancers on-prem is it has been all there all the time.
Another question.
Yeah.
Have you had any problems with upgrading Rancher clusters? One thing that I dislike about it, that I like about KubeADM instead, is that you can go slow and just upgrade this node and then go this node and you wait a week and then you upgrade that node. Rancher feels like you do upgrade and then you hope for the best and cross your fingers that okay, it worked or it didn't.
Yeah, what you can do, like there is this thing called we have a cluster right here, and I think snapshots is before I upgrade I always take a snapshot, and then as you said